It's pretty cold in Tasmania at the moment. This is an old clock project, actually, which includes a DS3231, which has an onboard temperature compensation. And so it's registering around 10 degrees. I'll come back to this clock in another video, but I just need it for calibration at this stage. So around 10 degrees down here in the workshop. It's actually snowing outside, so a little cooler, probably 3 or 4 degrees cooler. And what I've got on the breadboard is an LMT85, which is a temperature chip that has come in for another project. But I've been looking at these low temperature indicators, which are on our roads here in Tasmania. And the theory is, I think they were installed about 7 or 8 years ago. And the theory is that when it gets below about 5 degrees, they start flashing blue. And then the driver knows that you need to take care. And a pretty good idea, but there's on the stretch of road where they're installed all this time later, there's probably only about 5 or 6 that are still working. And I thought maybe I'll come up with my own version. It won't be installed in the middle of the road. In fact, I think it's a pretty strange idea because it is difficult to get to for servicing. But I do have a few of these things, which a few years ago you could pick up for around $1. And they're just garden lights, really. But what's inside is some circuitry which picks up the solar light during the day, and then at night time just comes on with a steady light, which is fine. And we've seen projects before, which I'll link up here, where I have modified these, and that's exactly what I'm going to do at the moment. But the modification that I've done before is just a steady flashing blue light. But this one, what I want to do is I want to actually have it so that it measures the temperature and then flashes a blue light for the time that it's below a certain degrees. I'd be probably interested in when it goes below about 8 degrees actually, and hence the calibration of the LMT85. So you can't normally run a microcontroller from a 1.2 volt nickel metal hydride battery. But you may recall the stable Joule Thief project, which I'll also link up here, and it allows you, using the QX5252, to actually supply a pretty steady current to an ATtiny. In this case, I think I'll use an ATtiny 13. And it does that with a few components. There's a diode here, a Zener diode, a capacitor, an inductor, and of course the QX5252 itself. So I've got my ATtiny 13. I'll pop it onto here and do some programming of it. I'll probably put a little cradle in here with some female headers so I can just pop it on and off for reprogramming. And most of the components are here. This is an LMT85. I've also got an LMT35, and I'm interested to see what the difference, if any, is between those ones. And I've got a series of LEDs here, and in the end, I actually think I might use these guys. These are little 0805 ice blue, and I think that's more appropriate than just blue. So first thing to do is to just make sure this is working. So it's around 10 degrees here in the down here in the workshop, and you can see it's 10 degrees on the screen as well. So I'll just pop that up here. That's the just measuring from the serial monitor. And if I put my hand over here, it's just every 5 seconds. So you'll see that going up, and then then it'll just slowly go down again. You can also cool it down to below 0 with some air, some compressed air upside down and all that sort of stuff. The usual thing with a can of air. Just turn it upside down and you get some pretty cool stuff coming out. Cool in both senses of the word. But anyway, what I'm going to do is I'll build this guy. I'll strip all this out, and then we'll see if we can't get it doing something like flashing when it's below. Yeah, I think about 8 to 10 degrees would be nice. No, I'll just stick it outside and see how it goes. The other thing long term is to take out the ATtiny 13 and pop in a Padauk PFS 154 as well. I haven't done an awful lot of analog to digital conversion with the Padauk, so that would be what's driving that. Not that there's too much difference. I think actually the Padauk is can sleep a little bit better. in terms of using less energy, and I think it can also run a little slower. I'll have this running at 128 kilohertz to try and keep the current requirements down to a minimum. But yeah, we'll just get the ATtiny 13 version of it running first, and maybe we'll come back another time for the Padauk version. We're all soldered up. Just want to test to see that the voltage coming through from the Joule Thief is okay for that ATtiny sitting on here. So what I've got is I've got this rechargeable battery, which should be around about the same voltage as what you'd expect in the that garden light. So that's 1.27, and then coming out of the stable Joule Thief, so that will be pin 8 for VCC, and this will be ground 8.3. Oh, okay, that's a bit unexpected. I thought I put I think this is I thought it was a Zener running at around 4.7, I thought. So I'll swap that out and we'll try again. Right, so whatever that was, it certainly wasn't a Zener diode, so that's a bit weird. Good thing to check. So here we go with, again, we've got the battery at 1.27, that's fine. And coming out of the stable Joule Thief circuit now we have, oh, much better, 4.44. I think I put a 4.7 volt Zener in there. So 4.43 stable, very good. All right, let's keep going. I'm going to now do some testing on this with the, I think I'll swap to the LM35, not the LMT85. Anyway, we'll just keep going and see how we get on. We've got our ATtiny 13A running at 128 kilohertz, which is very slow. And the joy of that is that it's not using much energy at all. And in fact, I've got it running at 4.5-ish volts out of the Zener diode here. I've got 470 microhenry inductor here, which means that I'm using the data sheet. There should be around about maximum of maybe 9 milliamps, which is available to it. But of course, when it's sleeping, then it doesn't need anywhere near that. So it's down in the microamp level at that stage. And it is sleeping about every 2 seconds. This is not the final version of the software because I actually probably want to make it sleep for about 3 minutes. And then when it wakes up, it says, hey, what's the temperature? And then if the temperature is below 10 degrees, then it'll start flashing this LED. At the moment, the LED is flashing, I think it's somewhere between the 7 and 10 degree mark. It'll flash once every 2 seconds or so. If it's between 3 and 7-ish, it will flash twice. And if it's below 3 degrees and down to 0, it'll flash 3 times. The temperature probe is the LM35, so that's why I'm saying sort of 3-ish and 7-ish. It's in this configuration, it won't be that accurate, and I don't really care that much either. I'm just looking for an indication when I look out at night, roughly what the temperature is out there. So I've got my compressed air here, which when I turn this upside down and fire it onto that sensor, should start the flashing. There we go. Let's turn the light off so we can see it. That's only 2 flashes. Gee, put a bit more air on, don't be... What's that? There we go, 3. Yep. So that should be below 3 degrees. And we get the 3 flashes. We get the 2-second sleeping time. And then we get the 3 flashes again. So it's sleeping between measurements. And actually, when it's going into its blinking cycle, it's sleeping for the delay between flashes, which I think is around about 1/4 of a second. And it's even sleeping while it's actually flashing, which is around about, I think, 30 or 40 milliseconds. So in other words, most of the time asleep, and that's where your efficiencies are. This has now gone to 2 blinks, and so that's indicating somewhere between 3 and 7-ish degrees. Then it'll go to 1 blink between 7 and 10-ish degrees, and then it will not blink at all. I've gone with the blue LED as opposed to the ice blue, which is what I thought I was going to use, because testing it a couple of nights ago to see what I could see, the ice blue was fine actually, but it comes across as white, and I actually wanted that sort of cold, it's called cold, like ice blue or cold blue is the whiter one, which is strange, but this is a blue LED, and inside this little container here, which is the original garden LED light, it's pretty good, and you can spot it from quite a long way away. So we're at 1 flash now, so somewhere between 7 and 10 degrees, and it's pretty slow warming up because it is actually pretty cold here in the workshop, and of course the rate of change in temperature is linked to the difference between what this is when I spray the compressed air on it and what the outside is, and if the difference is not much, the rate's pretty slow. Thanks Isaac Newton for that one. And let's put my hand over a little bit to speed up the process so we can go back to, yes, that looks like it's now stopped. So that's put some light back on the subject again. So I'm thinking that that's pretty good at this stage. I'm going to change the code so that it is actually asleep most of the time. Let's say every 2 to 3 minutes it wakes up and checks it. And then the last thing to do is to pull all of the original bits and pieces out of this garden solar light and replace it with this guy. So yeah, coming along pretty well at the moment. Let's see what's in here. Very first time I bought these, there were some quite nice AA nickel metal hydride batteries inside. And the very last time I bought these, there were some very ordinary AAAs. But I'm actually keen to maybe leave them as the AAAs. Yeah, that's a AAA in there. I might leave it as that and just see what we can squeeze out of it. And if it's an issue later on, then I'll replace that as well. You can squeeze a AA in there because I have done that before. But what I'll do is I'll just take off this software, this PCB, and put on mine and feed probably have to feed some of it through to the other side actually. We don't need the on-off switch. It's going to be on the whole time. But let's get cracking on pulling all that apart. Under the hood, a little PCB with a YX8050. Pretty similar chip to the QX5252, and I've got some of these, but I just prefer the specs for the QX5252. But this little guy you can retrieve or recover from these boards as well. It does pretty much the same thing. That's the output to the LED. There's your inductor. That's what's left of the switch. So I'll keep that, because you never know. And let's swap in the little cold indicator PCB. So the ATtiny 13's been programmed with the new firmware. Same as what we've seen, but this time it's going to sleep for about 2.5 minutes before checking. So most of the time, this little guy won't be using hardly any juice. I'm just going to solder that onto this SOP to DIP adapter, and then it's going to sit up here, giving it a much lower profile than the prototype, so it fits into the space on the garden light. We've got an inductor at 470 microhenry Zener, and I've wound that back to a 4.1 volt Zener instead of the 4.7. So just trying to again save juice. There's your QX5252, the hero of the whole project. Got a Schottky in there, a 1N5817 with a much lower voltage drop. 47 microfarad capacitor. That's where your solar cell fits, and that's where your little battery goes. And then on the other side, just a little smoothing capacitor there, 100 nanofarad, and then a 10K between VCC and reset, and we are good to go. So yeah, let's get this soldered up and try and shove it into the space provided. That's the ATtiny 13 attached via that little 8-pin adapter, and I've just cut all the header pins off actually just to keep it that low profile. Yeah, so we're good to press on. I have reneged on an earlier commitment to use the original battery. I didn't realise it was a NiCad, and I'm not too fond of NiCads, so I've swapped this 200 milliamp hour battery out for a 600 milliamp hour battery, which is nickel metal hydride, which I think works a little bit better with the QX5252 anyway. There's the LM35 just hot glued to the side here. The board is upside down, and you can just see the cap poking through. That's the 47 microfarad cap just poking through the hole, which I widened slightly where the switch was originally. That's your LED, and yeah, it's all pretty neat. So let's put it back together, put it outside. It's pretty cold out there, and see if we can't get some blinking action. So it's somewhere between about 3 and 7 degrees out here. It's working pretty well. That's the circuit working for this week. We'll see you next time.